Hi folks, 2015 question C3. I hope you're keeping well. So to kick off, I've the setup of this question done to save time, and it was a nice handy question. In fairness, you can do all of the elevation and plan there. First thing you're asked there is the dihedral angle between surfaces A and B. Now, first thing we need is the line of intersection to identify the line of intersection. There it is between A and B. Then we're going to look in at that to get a true length of that line. Okay. So, and I'm going to bring 2 points Q and T as I call them there, okay? So we'll set up these guys. And I called the top there X, so I did. And there we have the true length there, okay? Now, 2 points to bring with us. We'll bring up points Q and T. And they have no height. And the next thing we need to do then is we need to look down along this so that we'll see this as a point view, okay? And now we measure back. There's a new view, 1 view back, 2 views back. So we get our compass there and we measure off the points. So that's the length for Q there. Get the length for T now, also on this line. T, Q. And the last one then is we need to measure is the distance from here to the line of intersection. I always say you always know you're measuring off the same point or the right XY line, because it's only when it's the same distance to X and to P there, it's called, it's the same distance, it's parallel to that, you know you're measuring off the right place, because the only way you get a point view. And that is your dihedral angle that you're asked for there. Looking at the question then, the next thing we're asked there is to draw the true shape of the surface C and hence determine the radius of the largest circle that can be contained within that surface. Okay, so different ways about going about that, but if you think about it, there's surface C there, okay? Now surface C, we're actually looking at an edge view of it here. The line QT would be, which is on the base, would be a true length because it's on the ground, okay? So this line here, and I'll just put it in blue, that line there, that's the edge view of the surface C, okay? And when we have an edge view, we can rabat that onto the ground and just bring it down. I'll just extend on our ground line there lightly. Put down your compass. So we're just rabatting this guy down onto the ground now. This guy's going to come straight out. And this now will be the true shape of surface C. Now, we're also asked there, when we got the true shape, determine the radius of the largest circle that can be contained within that surface, okay? So anytime you want to put the largest possible circle you can into a triangle you're looking at there, bisect any two of the angles. Now we'll only need to bisect one because this angle is already bisected here. So I'll just throw my compass on T here. And there, at that point now, we're down our compass and we should be able to draw in the largest possible sphere that this triangle can take. Okay, let me just throw him in a different color there to make him stand out. Now, so that's part C then. Now, two parts to part D, okay? So they're asked there in part D to determine the pitch of the surface A, okay? Now, when this, so that what we need to get from A then, we need to get an edge view of this, okay? Now, you could go around a couple of different ways, but the handiest way to do this would be to take a level line here. You could take a level line anywhere. But rule of geometry, if you have a line that's parallel to the XY line, and then the next line, it'll be a true length, okay? So where it hits over here, I'm just going to drop it down. Okay. And I'll just throw this line in red actually to make it stand out. So I put in a level line there. Now I already knew P, so that's why. So the handy thing about that is this gets us a true length. And if we have a true length line on a plane, we can look along it. So we can, and it'll let us see that plane as an edge view. So let's get my other set square now. So we'll just project on up this line first of all. X1, Y1. And we have Q here at the base. And we have X up there at the top. So this is getting us an edge view of A, of the surface A. And also by doing that now, we can determine the pitch for A there. Okay, so you can throw down your protractor there, measure it off, make it out to be 60 degrees. Okay. So different ways you could have gone about that, but that would probably be the handiest one. And that method of taking a level line is a very handy one to remember as well. Okay. So last part in D then, they're telling us that a lightning conductor is to be fitted to the building. Okay. The conductor is to run from the apex, which is the very top of the building. Okay. As I called it X there, to the outer edges of surface A. So it's going to go from X through P and down to Q, okay? And they want to know, determine indicating meters, the minimum length of the cable required, okay? So what is the length of the cable from here to here to here? Now, there's only one way we'd know that, and we'd have to get the true length of X to P, and we'd have to get the true length of P to Q, okay? Now, I'll just label in this here a second now, P and X there. So again, a couple of different ways about going about that, but we already have an edge view here. So if we look in at 90 degrees now, you would see a true shape of A. And once you can see a true shape of A, you could go ahead then and you could measure that. So and that's exactly what we're going to do. So I'll just set up my set squares here. Now I'm going to set up the XY line very close to this. X2, Y2. Now my distances are going to be way off if I go marking them off there, if I go measuring from this X1, Y1 line, okay, which is 2 views back. So what I'm going to do is I'm going to put a datum line in across here. So I'll just get another cutter there. So what is the datum line? It's just a temporary measuring line, okay? And always bring it down to the closest point. That's my datum line there. So I know now X is going to be here. P is going to be this distance here. You can see there, and I'll just transfer that over. And Q is going to be down here. Just mark it, set it up your compass there. And you mark it off. Now, that's a true shape there. And if that's the true shape, that means this guy is the true length, that guy is the true length, and that guy is a true length here, okay? Now, what we want to do is we've been asked to indicate the length of that in meters, okay? So I'm just going to continue on up a light line there. And I'm just going to, from P, rabat this guy out so I have a straight line to measure. Okay, and it's just fitting on the page nicely for me. So my distance now from here to there is what they want to know, okay? So I make it out to be 112, okay? And when we scale that up then, okay, that's going to, there's 112 meters, that's going to be 22.4 meters, okay? That's what I'm getting. So give or take a mil there. That's the distance there of the shortest cable required, okay? So that's that question, folks. It was a nice handy one, really, all to do with kind of true lengths, true shapes as usual, okay? So I hope you found that useful, folks. Stay safe, more videos to come. Take care.